Tom, will you have any introductory comments that you want to make, or?
I'd say you proceed.
Okay.
I will decrease while you will increase.
All right, we'll wait. The participants are entering now, so we'll allow that to taper.
I mean, as soon as it gets to 1,000, I'd say go ahead.
All right. We'll give it just another 30 seconds.
Good morning, Fabiola.
All right, let's get started. Good morning, good afternoon, good evening to all of you. We're delighted to have you join us so that we can share a lot of thoughts, perspectives about digital health education for clinical engineers. My name is Elliot Sloan. My co-moderator is my good friend and colleague, Ricardo Silva, and we have an excellent team of speakers. We also will be, during the presentations, we will be simultaneously English and Spanish, so that we'll have the opportunity to make it easier for everybody to participate and understand. I'll apologize in advance. I only have English to offer. Next slide, please. So these are our presenters. We'll be introducing them in just shortly. Next slide. And one more. Thank you. I have been at this intersection of clinical engineering and digital health since 1978. To put this kind of in a mental perspective, it was the era of mini computers, the early demise of mainframes. 1985 was the arrival of personal computers, and well, we all witnessed the iPhone and apps and the generation of digital health that is common around the planet. I've published in the area of 200 papers on these subjects, so I've spent a lot of time wrestling with some of these issues, and I'm still publishing 5 to 10 papers on every year on topics very broad-ranging. I've listed some of them there. It is an exciting, dynamic, growing field. I'd say 10 years ago, when I was talking with colleagues around the globe, they were very neutral about whether digital health would arrive. We have had 2 presentations at the ICE-HTMC congresses in 2019 in Rome and in 2021 virtually and in Washington, D.C. And I raised grand challenges and concepts related to digital health education for us, the clinical engineering community. Next slide. The focus of the presentation in 2021 said telemedicine and telehealth, but really it was all about digital health. And what we have seen in the COVID-19 pandemic is that telehealth, telemedicine, digital health, AI, ML have become a much more widely accepted, adopted, and daily practice for clinical care at all points of the globe. Clinical engineers are in a situation where we have to lead digital health. We are among the only professionals that work across all the various departments who have direct contact with patients, physicians, nurses, understand the dynamics of our local, national, and international healthcare systems. So it is our responsibility and privilege to expand our capabilities. Next slide. We talked about in 2021, last October, the body of knowledge that we need. And we talked about some of the conceptual areas that we are all concerned about. The digital hospital, whatever portions of a hospital are digital. Again, 10 years ago, many hospitals said we don't use digital technologies. But as you look at lab, radiology, general medical records, telemedicine, telehealth, Zoom, all the modalities of touching and contacting patients, connecting physicians and nurses, have all implemented and deployed tools, WhatsApp, Instagram. It's amazing how many tools have been deployed to meet the need. Home patient care, remote patient monitoring, patient and hospital at home techniques and technologies, so much artificial intelligence and decision support tools to try to determine what is the best treatment for patients with COVID and more other illnesses, and all of the underlying health technology assessment, management, risk management, quality are needed to properly support these emerging technologies. And our goal in that presentation was talking about developing a CE education, training, accreditation, and certification as needed. Next slide. We identified a number of topic areas. I'm not going to read all of these, but I want to point out that mobile technologies, augmented intelligence, systems engineering, the fact is that these products are parts of larger systems of systems that have to be managed properly. All the confidentiality, privacy, all the safety to avoid harm, informed consent for patients. All of that is required for us to expand our field and make sure that 21st century healthcare is not just acceptable, but excellent. Next slide. Now I'm going to transition to my colleague and friend, Professor Ricardo Silva, and our speakers, and they're each going to offer their perspectives about how we can and will support clinical engineering digital health competency development in the years ahead. And this is a major project for our IFMBE CED community. Ricardo?
Thank you, Elliot. So like Elliot was saying, this is a great opportunity for us to launch this initiative. At this point of time, I want to welcome everybody. Good morning, good day, good afternoon to all. And I'm going to introduce our speakers from Colombia. So what our friends from Medellin did is they pre-recorded their presentation so that it could be uploaded with automatic subtitles in English. Presentations are in Spanish with subtitles in English. Caleroy, it's going to show how this presentation was already uploaded into the YouTube channel, and she's actually auto-generating the subtitles in English for all of us to follow. Well, so with this, let's see the presentations from our speakers. After that, I'll have a brief presentation and we will have a wonderful discussion panel for all of you. Thank you. Caldi, we are missing the volume.
Digital y hablar alrededor de esto sobre las oportunidades y los diferentes retos que trae para la salud, para los hospitales y en general para la ingeniería clínica, el discutir este tipo de temas. Soy Javier Camacho, soy docente e investigador en el área de ingeniería clínica en la Universidad EIA de la ciudad de Medellín, Colombia. Y este tema arranca conociendo una realidad y es el alto crecimiento de datos e información que está invadiendo los hospitales y el sector salud en general. Y esto es bueno, que los datos crezcan, que los datos estén disponibles. Y como vemos en la pantalla, este crecimiento ha dejado de ser lineal para tener en los últimos años un comportamiento más bien de tipo exponencial. De hecho, se estima que para el año 2025 ya estemos hablando de cerca de 12 zettabytes de información que quizás puedan estar disponibles para el desarrollo de toda una cantidad de soluciones y de desarrollo de dispositivos y desarrollo de toda una cantidad de proyectos quizás alrededor de, de ofrecer a la salud una medicina de precisión, de generar desarrollos alrededor posiblemente de inteligencia artificial, pretendiendo entregarle nuevas soluciones a los médicos en el tema de la toma de decisiones alrededor de la salud. Pero, digamos, ligado a esos temas se encuentran los desafíos, como por ejemplo un desafío muy importante como lo es la interoperabilidad en el sector salud y más en países en vía de desarrollo como Latinoamérica, y asimismo una gran amenaza la cual tenemos que enfrentar como lo es la ciberseguridad. Alrededor de la medicina de precisión, lo que tenemos que tener claro es que existen diferencias muy significativas entre pacientes de diferentes ciudades y pacientes de diferentes países, ¿cierto? Y de acuerdo a eso, entonces los tratamientos han sido más bien imprecisos. Por ejemplo, en unidades de cuidado intensivo han sido realmente imprecisos y vale la pena pensar en soluciones pensadas en una población, digamos, específica, en una medicina que trate al paciente de forma individual. Sabemos que, por ejemplo, entre países como Estados Unidos y el resto de países de Latinoamérica, existe realmente una gran diferencia en nuestra raza. Este es un estudio que realizamos comparando la base de datos norteamericana MIMIC con una institución de salud de Colombia y asimismo alrededor de esta diferencia encontramos diferencias bastante significativas con respecto incluso a los virus, a las bacterias que nos afectan. Naranja es la base de datos norteamericana y azul lo que encontramos en nuestra población. De modo que existen diferencias incluso partiendo de las enfermedades que se abordan o las cuales se enfrentan nuestros médicos. Y alrededor de esto es que entonces tenemos que pensar porque los tratamientos son diferentes y tienen que estar pensados de acuerdo a esta población, a que somos una población diferente, que nos enfrentamos a enfermedades diferentes y por lo tanto nuestra población merece y necesita, por lo tanto, soluciones particulares, ¿cierto? Alrededor de este tema entonces surge toda una nueva oportunidad de utilizar herramientas basadas en nuevos desarrollos, como lo es Machine Learning, como lo es inteligencia artificial, toda una nueva ola de tecnologías y de desarrollos que están disponibles ahora con las velocidades de procesamiento de la tecnología permite entonces utilizar estas nuevas técnicas para poder ofrecerle al personal asistencial nuevas herramientas para la toma de decisiones, una toma de decisiones más ágil, una toma de decisiones pensada en los pacientes. Y alrededor de esto, desde nuestra universidad hemos tenido la oportunidad de desarrollar productos pensados en eso. Entonces desarrollamos un producto basado en inteligencia artificial que le permite a los médicos de las unidades de cuidado intensivo predecir una condición tan compleja como lo es la sepsis en dos configuraciones. Una configuración básica pensado en la utilidad de datos de tipo demográfico y datos fisiológicos que tradicionalmente están disponibles en las unidades de cuidado intensivo y una configuración avanzada que le permite al médico aprovechar un poco más de información y de datos que están disponibles en las unidades de cuidado intensivo, como por ejemplo exámenes de laboratorio clínico, gases arteriales y demás, y que le permitiría en este caso al modelo entregarle al médico nuevas soluciones. Pero alrededor de este tema existen unos desafíos que vale la pena considerar y que nos encontramos durante nuestro estudio, y es un desafío muy importante como lo es la interoperabilidad. Este es el resultado de una encuesta realizada en Latinoamérica y se ven toda una serie de desafíos como lo es la privacidad. Necesitamos fortalecer nuestras capacidades, necesitamos intercambiar información, tener nuevos métodos analíticos, en este caso como la inteligencia artificial, promocionar estándares de interoperabilidad, pero realmente hay algo que nos preocupa y es la falta de integración entre los diferentes sistemas de información, entre las diferentes tecnologías, y hacia esto debemos trabajar los ingenieros clínicos, los ingenieros biomédicos, hacia ofrecer soluciones, ojalá de bajo costo, pero que permitan sanar estos desafíos que están al día de hoy y son los desafíos que nos van a impedir avanzar en la utilización de nuevas herramientas como lo es el Machine Learning y como lo es la inteligencia artificial. Entonces, este es el panorama que nos encontramos el día de hoy. Esta imagen tomada de IMSS nos permite observar cómo las instituciones de salud tienen toda una cantidad de centros o de fuentes de información provenientes de unidades como dermatología, radiología, cardiología, pero todas actúan como silos independientes, almacenando quizás información de mala calidad. Todo esto finalmente afecta la eficiencia en el cuidado de los pacientes y asimismo aumenta gastos. Y no es lo que se quiere. Lo que queremos, digamos, y necesitamos trabajar urgentemente es en unificar los sistemas de información, en unificar la forma de transmitir la información y de poder almacenar los datos para que estos finalmente se conviertan en información útil, en conocimiento que le sirva finalmente al médico. Entonces debemos de trabajar urgentemente en la interoperabilidad. El segundo desafío que vale la pena trabajar es en ciberseguridad. Claro, a medida que vamos introduciendo tecnologías ligadas al uso de información, pues el tema de la ciberseguridad está como top número uno y está a la orden del día y vale la pena trabajar en ello. Estas son indicaciones de un estudio reciente donde nos muestra cómo, por ejemplo, tecnologías como las bombas de infusión tienen la vulnerabilidad de ser manipuladas de forma remota y se pueden incluso manipular las dosis y afectar finalmente la seguridad de nuestros pacientes o como fabricantes como Medtronic y GE Healthcare con sus diferentes tecnologías que si bien permiten, digamos, tratar datos e información, tienen la vulnerabilidad de alterarse de forma remota y someter a riesgos bastante complejos de los pacientes. Y alrededor de este tema, Colombia fue o ha sido víctima de ciberataques. De hecho, una de las instituciones más importantes de Colombia, como lo es el INVIMA, el Instituto de Vigilancia y de Medicamentos y Alimentos, ha tenido una experiencia bastante compleja recientemente y fue, digamos, atacada con hackers y realmente esto puso en jaque a esta institución tan importante. De modo que es un desafío que tenemos y es algo que vale la pena abordar, tanto la interoperabilidad, tanto el aprovechamiento de los datos, ojalá trabajados en términos de calidad, de modo que tenemos que trabajar de forma integrada y articulada los diferentes actores, los médicos, la ingeniería clínica y los profesionales de la informática. Entonces, esta es nuestra invitación, que trabajemos en conjunto para poder abordar estos retos que nos demanda la salud digital de hoy y del futuro. Muchísimas gracias por el tiempo.
Cordial saludo. Mi nombre es Beatriz Janet Galeano Upegui. Soy ingeniera mecánica, magíster en ingeniería y docente de la Universidad Pontificia Bolivariana. En esta oportunidad les vamos a hablar de la academia de cara a los retos y oportunidades que presenta la salud digital.
Mi nombre es Nelson Javier Escobar Mora, soy ingeniero mecánico, magíster en ingeniería y trabajo en la Universidad Pontificia Bolivariana de Medellín, Colombia. El día de hoy les hablaremos con la siguiente agenda. Primero hablaremos sobre la academia, la ingeniería biomédica en Colombia, la academia y su impacto frente a los retos y oportunidades que plantea la salud digital en Colombia. Hablaremos sobre lo que es el CONIC y realizaremos unas breves conclusiones de toda esta información que les vamos a presentar. Lo primero que hicimos fue buscar en las bases de datos del Ministerio de Educación de Colombia, buscando obtener el número de pregrados en ingeniería biomédica con los que cuenta el país. Y encontramos que existen registrados en la base de datos activos al día de hoy 22 programas de ingeniería biomédica. Y luego buscamos los pregrados asociados a bioingeniería y nos dimos cuenta de que existen 4 pregrados activos con esta denominación de bioingeniería. Luego nos dimos a la tarea de buscar cómo los posgrados estaban denominados en Colombia en la misma base de datos del Ministerio de Educación Nacional y encontramos que existen 5 maestrías con denominación de Ingeniería Biomédica y un programa de especialización que en Ingeniería Biomédica. Y en bioingeniería existen 7 programas, de los cuales 4 son de maestría, 1 es de doctorado y 2 son de especialización.
A partir de estos datos, entonces también quisimos corroborar cuál era la condición actual de los egresados de estos programas, cómo estaban en términos de empleabilidad y cómo eran los salarios o en qué promedio estaban los salarios de los egresados de los programas de pregrado particularmente y el costo promedio de la carrera. Entonces encontramos que el programa de ingeniería biomédica cuenta al 2020 con 2.901 egresados, de los cuales el 90.82% se encuentra registrado en las bases de la Seguridad Social en Colombia, por lo tanto, se asume que están empleados. Y en bioingeniería tenemos 557 egresados, de los cuales 71.45% están registrados en las bases de seguridad social. Por lo tanto, nuevamente se asume que están empleados. El salario promedio que están ganando los recién graduados de estas carreras en el país está alrededor de los $650 y el costo promedio de las carreras, este sí es para ambas denominaciones, está alrededor de los $20.000 en todos, incluyendo todos los semestres que deben cursar los
Nos
estudiantes.
dimos a la tarea de buscar en esas 26 programas de pregrado, con las 2 denominaciones, tanto ingeniería biomédica como bioingeniería, todos sus planes de estudios. Existen carreras que tienen 8 semestres, hay otras que tienen 9 semestres y otras que tienen 10 semestres. Buscamos aleatoriamente dentro de esas 26 instituciones y logramos determinar o encontrar o evidenciar que existen algunas similitudes en estos programas que nos permiten decir que no existen cursos específicos en el pregrado que aborden la salud digital. Dentro de cuáles ítems, de los 4 ítems que estamos manejando, como es la medicina de precisión, la inteligencia artificial, la interoperabilidad y la seguridad. Cuando hablamos de que no se evidencian estos cursos de forma directa, es porque vemos, creemos y consideramos que estos temas están abordados dentro de unos cursos específicos que son muy repetitivos en cada una de esas pensum o de esos contenidos que analizamos, como son la informática médica, la telemedicina, y también evidenciamos que existen muchos programas que tienen cursos electivos y optativos dentro de los cuales se abordan estos temas, pero no tienen las denominaciones exactamente ajustadas como son medicina de precisión, inteligencia artificial, interoperabilidad y seguridad. Adicionalmente, se evidencia que en estos programas mínimo existen entre 1 y 2 cursos de ingeniería clínica, lo cual da pie para que nos apoyemos, para que sigamos trabajando y sigamos fortaleciendo todo este tema que venimos haciendo en cuanto a la ingeniería clínica en los pregrados a nivel de Colombia. En los sistemas de posgrado, pues entonces sí encontramos que la mayoría de los posgrados, pues abordan estos temas ya de forma específica en las especializaciones, en las maestrías y en los doctorados, donde tienen cursos con la misma denominación, o que los trabajos realizados o que los trabajos reportados en la literatura por los grupos de investigación, en papers, en ponencias, en revistas indexadas o en eventos de socialización como seminarios, congresos, etcétera, etcétera, están relacionados con estos 4 ítems que venimos trabajando de la salud digital en Colombia. Esto evidencia que las instituciones de educación superior en Colombia están realizando trabajo, están abordando y están haciendo investigación en estos temas que asociados a los retos y oportunidades que plantea la salud
Pero
digital.
adicionalmente encontramos que hay otras formas en que desde la academia se está manejando el tema de salud digital en Colombia y están asociadas al entrenamiento, la investigación y las alianzas estratégicas. Cuando hablamos de entrenamiento, podemos tener en cuenta elementos como el relacionamiento con expertos en estos temas a nivel mundial, intercambios y pasantías en universidades nacionales e internacionales que están profundizando en estas temáticas, visitas de referenciación a instituciones hospitalarias donde se están aplicando temas asociados a la salud digital, conferencias, webinars, seminarios, foros, congresos, donde se habla de la temática orientada a la salud digital, los retos que están generando y los impactos para la organización de las instituciones prestadoras de salud a futuro. Y los procesos de certificación en algunas temáticas específicas que ayudan a soportar y a apoyar la implementación de este tipo de tecnologías. Adicionalmente, si hablamos de temas de investigación, encontramos que en este momento hay orientación dentro de la investigación en bioingeniería, en incluso otras ingenierías que son afines al tema de la salud, y en desarrollos de investigación asociado, que vinculen o que asocian personal de la salud con personal técnico en temas como interoperabilidad, inteligencia artificial, ciberseguridad, informática médica, transformación digital, robótica médica, transformación de la infraestructura hospitalaria a partir de los requerimientos planteados por la salud digital, porque todos estos retos nos van a llevar a generar cambios en la infraestructura hospitalaria, entonces también ese tema se está investigando, al igual que el impacto que genera en la sostenibilidad y la economía circular derivada de los procesos de implementación de la salud digital, y cómo se van a dar retos y oportunidades también para asociar o vincular el tema de gestión dentro de los elementos que se deben gestionar y que se deben manejar a la hora de administrar la tecnología de salud en las organizaciones. Si hablamos de alianzas estratégicas, pues es la posibilidad que tienen las instituciones académicas de realizar alianzas con otras entidades para poder llevar a cabo estos procesos de entrenamiento e investigación y de pasantía con los estudiantes. Entonces, alianzas estratégicas entre las mismas universidades que están trabajando los temas, con instituciones prestadoras de servicios de salud, con la industria desarrollando proyectos en conjunto, con el gobierno, además de que se aprovechan las oportunidades que presenta el Ministerio de Ciencia y Tecnología para generar proyectos de investigación y para generar procesos de regulación y de salud pública que también se van a ver impactados por todo lo que tiene que ver con la salud digital, porque hay que empezar a reglamentar y regular la implementación de la salud digital en el país. Asociaciones nacionales e internacionales e instituciones que apoyan procesos de investigación. En este caso, pues nosotros podemos hablar directamente del trabajo que venimos haciendo las instituciones universitarias desde el CONIC y las alianzas y el apoyo que venimos desarrollando con la Alianza Global de Ingeniería Clínica, la participación que tenemos en estos espacios. ¿Qué estamos haciendo entonces las universidades miembros del CONIC? Estamos desarrollando actividades con visión de futuro desde el Congreso de Ingeniería Clínica y los eventos que podemos desarrollar a partir de él o las actividades que podemos desarrollar. En este caso el CONIC está conformado por 4 universidades de la ciudad de Medellín que se unieron para trabajar en conjunto en temas asociados a ingeniería clínica y para difundir los conocimientos y motivar el desarrollo de esta disciplina en nuestra ciudad y en nuestro país. En este caso las universidades son la Escuela de Ingeniería de Antioquia, el Instituto Tecnológico Metropolitano, que es una institución universitaria pública, la Universidad de Antioquia, que es otra universidad pública en el país, y la Universidad Pontificia Bolivariana. Las dos universidades privadas somos la Bolivariana y la Escuela de Ingeniería de Antioquia. ¿Y qué buscamos? Potenciar la ingeniería clínica a partir de un modelo de colaboración interinstitucional que busca relacionar el gobierno, la industria y las instituciones de salud con la academia a través de eventos, procesos de investigación y desarrollo, redes de trabajo y cooperación que se asocian desde las necesidades del país, los avances internacionales en ingeniería clínica y la continua exploración de las necesidades y los requerimientos del país para a través de un plan o un proceso enfocado en la calidad de los productos que podemos desarrollar, pues generar conocimiento, generar capacitación, generar entrenamiento y generar impacto e innovación a partir de los procesos de investigación.
Bueno, esta historia la empezamos en 2014. Realizamos el primer Congreso Internacional de Ingeniería Clínica, el cual fue realizado en la ciudad de Bogotá. Luego, la segunda versión ya la hicimos en el año 2015 en la ciudad de Medellín y desde ahí ha sido itinerante, es decir, lo hemos hecho cada 2 años. Luego, por la contingencia de COVID, pues nos vimos postergados a la próxima sesión que va a ser en 2023, en el cual están cordialmente invitados y les hablaremos ahorita, pero el tercer congreso lo hicimos en 2017, el cuarto lo hicimos en 2019 y estos son algunos resultados que les queremos mostrar. En el 2015 tuvimos 219 asistentes, tuvimos 22 papers, 4 conferencistas nacionales y 4 internacionales. Luego en 2017 tuvimos 222 asistentes, 35 papers, 4 conferencistas nacionales y 6 internacionales. Y en 2019 tuvimos 266 asistentes, 25 papers publicados y 5 conferencistas nacionales y 6 conferencistas internacionales, lo cual nos da pie para decir que hemos hecho nuestro trabajo haciendo difusión de todos estos temas y en los cuales hemos venido trabajando en los temas de salud digital, ¿cierto? Algunos aliados y patrocinadores, pues pueden ver que aquí están los aliados nacionales en los cuales hemos contado con el Ministerio de Salud, hemos contado con la ANDI, que es la Asociación Nacional de Industriales, el INVIMA y Colsin, que es el Colegio Colombiano de Ingeniería Clínica, del cual algunos de los participantes pues somos miembros fundadores.
También pues es importante hablar de que hemos trabajado con aliados internacionales, que en este caso son el Colegio Americano de Ingeniería Clínica y la División de Ingeniería Clínica de la IFME, y que a partir del tercer congreso venimos siendo colaboradores o participando como colaboradores de la Alianza Global de Ingeniería Clínica.
¿Qué impactos hemos generado? Entonces, hemos generado una gran sinergia entre las instituciones de educación superior del sector público y privado, como lo contaba mi compañera Beatriz. Adicionalmente, hemos realizado ponencias en eventos organizados por grandes instituciones como la Organización Mundial de la Salud, la Organización Panamericana de la Salud, el CGA y la ANDI, ¿cierto? Adicionalmente, hemos trabajado con el CGA para la difusión y posicionamiento de CONIC en el ámbito internacional, logrando un reconocimiento académico a nivel empresarial, ¿cierto?, como organizadores del evento. Es decir, ya la industria colombiana de este sector nos reconoce, nos tienen en mente para el evento y siempre pues tratan de participar y mostrar sus adelantos. En estas versiones que hemos hecho, pues han mostrado sus adelantos, inclusive algunos aportes que han hecho a todo la salud digital.
A partir de esta información, entonces queremos invitarlos para el quinto Congreso Internacional de Ingeniería Clínica, que se va a realizar el 30 y 31 de marzo del 2023 y que tiene el objetivo de lograr que los profesionales, las instituciones prestadoras de servicios de salud, las entidades estatales y los proveedores de dispositivos médicos interactúen buscando unir lazos de trabajo y que puedan socializar sus necesidades y desarrollos en el ámbito de la ingeniería clínica, tanto a nivel nacional como internacional. En este caso, pues vamos a tener como la presidencia en cabeza de la Universidad de Antioquia. La Escuela de Ingeniería de Antioquia va a ser la administradora del evento. Esperamos contar mínimo con 7 ponentes internacionales y 2 nacionales y esperamos una participación mínima de 300 asistentes. Entonces están cordialmente invitados. Les vamos a contar ahora las temáticas sobre las que vamos a trabajar para que se animen a presentar sus trabajos y a participar con nosotros del evento y a visitar una ciudad tan bonita como Medellín, la ciudad de la eterna primavera. Las líneas temáticas son el hospital digital, transformación digital, informática médica, inteligencia artificial. Vamos a hablar de dispositivos médicos, investigación y desarrollo, sostenibilidad, ciberseguridad e infraestructura y gestión de la tecnología hospitalaria. Nuestra intención con este evento es fortalecer las relaciones y las buenas prácticas que se dan en nuestro país a partir del conocimiento y la experiencia, tanto de los nacionales como de los internacionales, que hacen o que facilitan y ayudan a enriquecer la experiencia del trabajo en ingeniería clínica a nivel docente, a nivel de investigación, a nivel práctico, a nivel de extensión. Entonces, bienvenidos todos.
Como conclusión de toda esta información que les hemos mostrado, queremos abordar en el evento estas siguientes temáticas. Por ejemplo, queremos continuar con la alianza entre las 4 instituciones de educación superior para contribuir al posicionamiento de las mismas a nivel nacional e internacional. Por eso estamos trabajando con diferentes instituciones nacionales e internacionales como lo hemos venido trabajando, ¿cierto? Otra es que hemos generado espacios de reflexión, ¿cierto? En los cuales a través de nuestros análisis y mecanismos de prospectiva hemos logrado mantener la ingeniería clínica o buscar que la ingeniería clínica permanezca actualizada y conectada, ¿cierto? Generando debate con los diferentes sectores a nivel nacional e internacional.
Adicionalmente, pues buscamos el apoyo de los líderes de cada institución de educación superior y con los interesados en trabajar con nosotros y en aportar a este conocimiento para potenciar el desarrollo académico, investigativo y de extensión desde las alianzas que podamos establecer, ya sea nuevamente entre nosotros con otras organizaciones. Y pues abonar el camino para lograr un desarrollo integral de un modelo interuniversitario que permita el mejoramiento de la ingeniería clínica, no solo en el país, sino en América Latina, a partir de la alianza con otras instituciones universitarias y de la alianza con organizaciones como el Global o la Alianza Global de Ingeniería Clínica. Les agradecemos mucho pues el habernos escuchado, esperamos poder aportar desde el desarrollo de las actividades que hacemos, desde el mismo CONIC para todos ustedes, y bueno, esperamos poder compartir con ustedes nuestro próximo evento en el 2023.
Muchas gracias. Quedamos atentos la academia de cara a los retos y oportunidades que presenta la salud digital.
Well, thank you to Javier, Beatriz, and Nelson. I want to let everybody know that they are all present here. And after my brief presentation, we're going to open the panel for discussions. There is the chat that has been very active, but besides the chats, there's a question and answer button. So far, there was one question asked and already answered, and I might want to come back to the question and answer when we open the panel, but feel free to use the questions and answers to ask your questions so that they can be debated in the upcoming panel. I just want to say a couple of things about our prior presentations. This is a great example of how 4 academic institutions are participating in an active collaboration with government, industry, and accreditation entities. And this example is something that we could also bring to the conversation because people from other countries might want to learn from this collaboration in order to move forward clinical, biomedical, and health IT in the respective nations. So right now, I'm representing the Healthcare Technology Certification Commission, which is the entity in the United States that certifies clinical engineers. However, this proposal is not an official proposal from the Health Technology Certification Commission. This is being discussed at the moment. And after my presentation, if you think that this is a worthwhile project that should be pursued, I would be very grateful if you could write your support via email to either myself, Elliot, Tom, so that we can bring it to the clinical engineering panel and move forward with this idea. Let's move to the next slide, Callie. So Clinical engineering, as defined by the American College of Clinical Engineering, is a profession that supports and advances patient care by applying engineering and management skills to healthcare technology. Healthcare technology includes the area of information technology. There is a long definition here of information technology from the National Institute of Standards and Technology, but suffice it is to say that IT is essentially all of the movement of information and data through digital media. So with that, let's go to the next one, Callie. I venture to propose a definition for clinical engineering information technology as a professional who supports and advances patient care by applying engineering and managerial skills to information technologies, but not any information technology, but those used for digital health interventions. And for that, I'm using the definition by WHO, where digital health interventions are the different ways in which digital and mobile technologies are used to support health system needs. Javier Beatriz Delson did an excellent job presenting some of the health system needs for clinical engineering. Elliot has been working in this field for longer than anyone, and he has been aware of all of the changes. However, this is a field that is continually evolving. So how can we keep up to date with the changes in technology? Let's go to the next one, Callie. So the World Health Organization actually created a group for digital health interventions. And they published a very interesting document last year to classify, catalog all of the different digital health interventions and what are the challenges, what are the categories, and what are the kinds of resources that are needed to support these challenges in the specific categories. Here is the link to that publication. I invite you all to read and follow it because it's the basic starting ground for all of our further discussions. Let's go to the next one, Callie. So why clinical engineering information technology? Well, this slide from a presentation that Tom did in 2019 at the Chinese Society of Clinical Engineering as part of Advanced Clinical Engineering Review course. And as everybody is aware, today, medical devices are actually connected devices. Every piece of hardware in healthcare setting is now able to connect to a network. That makes health information part of the IT platform. So there are a lot of things that we have to fulfill. Here are some of Tom's notes. Elliot introduced and presented some notes. Javier did the same thing, presenting some notes: interoperability, cybersecurity, health informatics, patient engagement, connected device, wearable technologies, ubiquitous technologies. The truth is that healthcare, it's moving from what we currently know as the hospital, as a concentrated institution, to distributed care. And how do we guarantee that all of those distributed devices are compliant and providing the best quality of care? Well, clinical engineers need to be aware of the technology and how to move forward with it. Let's go with the next one, Cal. So what is my proposal? My proposal is to have a continual accreditation program based on the use of continual education units. So people will be able to acquire these continual education units. The idea is to proctor these units so that we assure that the quality is there. And by assuring the quality of the units, we know that people are actually keeping up to date with the newest technology trends. Let's go to the next one, Callie. So who is currently providing continual education units and certifying them? No one. No one is doing that, and someone should take the lead. Let's go to the next one. So what is my proposal? again, this is not yet an official proposal from ACCE, but with your support, we can make it happen. Well, the idea is that we can gain continual education credits through different processes. We can attend seminars such as this one, and after the seminar have an exit exam that will verify, certify your learning outcomes, and we can provide credits for that. You could actually do a formal technical training course, and we could apply those credits, or we could validate the work and the experience that you have in this area by everything that you're doing via CEIT community and the validation of that. Let's go to the next one, Cal. The idea is that this would be a continuous 3-year process. So every 3 years, we should go through a re-accreditation requirement. Why? Because this is changing all the time. The only way we can stay up to date with the immense change, and Javier presented the exponential growth of healthcare IT, is by continually updating our skills and having someone continually validating those skills so that your employers, your institutions, the academia are certain that you are keeping up to date with the technology trends. Let's go to the next one, Calvin. So how do we want to do it? We do not want to reinvent the wheel. There are many institutions such as the IFMBE that are hosting this sort of seminars. Can we take the opportunity, can we take these seminars and provide credit to them by assessing the exit exam? I'm proposing that HTCC could proctor these exams and keep the scoreboard for all participants. That way, the cumulative credits will be counted at the end of the 3-year period. And if you met the accreditation or re-accreditation requirements, your CEIT certificate will be updated and renewed. And again, everyone in the field will know that you've been keeping up to date. Let's go to the next one, Kelly. So what is the advantage? What do we gain? Well, we promote continual education. We increase the body of knowledge for clinical engineering and health technology management. We stimulate collaborating partners to generate and update content. So all of you in this presentation could become content generation centers. And you could also get accredited or receive continual education credits for the content that you are generating. In fact, the Antioquia consortium that initiated this panel, it's part of the first group of collaborating entities. So let's go to the next one, Calvin. So here we have some of the early promoters of this technology. We have the American College of Clinical Engineering, American Association for Medical Instrumentation, Health Informatics Management System Society, of course, International Federation for Medical and Biological Engineering. And here we have the Medellin cluster in Colombia, who already wants to move forward with proposing content also as part of the Clinical Engineering Congress that they're going to be hosting in 2023. So let's go to the next one. In summary, what do we want? We want people to generate content. We want that content to be validated by an entity such as HTCC to guarantee that the quality of the content is there and that the participant actually did receive knowledge from its participation. We can add all of the sources of content. We accumulate essentially 10 continual education credits per year for a total of 30 credits in a 3-year period that will provide you your accreditation. And as long as you continuously update your knowledge in the next 3-year cycle, you would get your accreditation updated. Go to the next one, Callie. So with that, thank you. Please remember to use the questions and answers to ask your questions. Please remember to email Tom, Elliot, or myself your opinions regarding this continual education process. And with that, I think it's time for our discussion panel.
Yes, and please, panelists, turn your videos on and microphones on so that we can work our way through the questions and engage in the discussions. We have a number of questions that have come up. Well, one of them, perhaps we can revisit for a moment, is the definition of data quality. And quality is a complex subject because quality is in the eye of the beholder. You may go to one restaurant and find it's wonderful, and I may go to that same restaurant and find it's terrible. A patient may have a telemedicine experience and feel that it is very helpful, and another may feel that it is very impersonal and overwhelming. So what does the data mean? We also have data related to metadata, interpreted data, averages. We have other kinds of data that has to be interpreted and translated between different systems. We have a concept in data called provenance or provenance. Where did the data come from? Is it from a very inexpensive home care device? Or is it a device that is perhaps a high quality scientific device? The precision, accuracy, and reliability and trustability may be different. Ricardo, since we have a multilingual audience, I'm wondering, I don't think we can afford to spend the time to translate everything, but I do think that we should allow our panelists to speak on these topics, and you may need to help them to communicate in English for the rest of the audience.
Of course, Elliot, thank you very much. I think Javier already responded to this first question. An important aspect that he did not mention is that this specific AI software for the detection of massive infections leading to sepsis actually was his doctoral dissertation. So Javier actually analyzed the quality of the data so that he could properly develop his expert system. So he definitely has skin in the game, and maybe Javier, you might want to add a little more to that specific question.
Possible to speak in Spanish?
Puedes hablar en español y yo traduzco, no te preocupes.
Vale. Sí, el reto o el mayor reto que se tuvo con el estudio, con el uso de datos, definitivamente es la calidad. Conversando con los clínicos, con los médicos, ellos son conscientes de que el ingreso de la información que ellos hacen a través de los sistemas de información que tienen los hospitales realmente, digamos, no es bueno. De hecho, el problema parte desde ellos como usuarios de la información. Es decir, los clínicos quieren y necesitan estar capacitados en cómo ingresar la información al sistema de información clínico. Segundo, es importante incluir en estos temas a los ingenieros de sistemas.
Let me interrupt you just for a moment and ask you to pause periodically. Let Ricardo explain in English.
Yes.
Thank you.
Thank you, Ricardo.
Thank you, Elliot. So Javier was making a very interesting point. He said that for his dissertation and his AI development, it was fundamental to get good quality of data. And actually, the medical doctors did understand that data quality was paramount, was essential. But the problem is twofold. On one hand, you need the systems, the devices that will provide you with the raw data. But in the other hand, you also need the doctor, the expert opinion, to be fed into the system. And this medical opinion needs to be fed in a way that is actually machine readable, in a way that is standardized so that it can be analyzed by the computer. So actually training the medical doctor and providing them with a standardized systems and values so that they can input high quality data, high quality information is also very important when answering this question about the quality of data.
Javier, you can continue. I'm sorry.
Y digamos, el segundo aspecto definitivamente es la integración de los datos. El universo de información que existe en salud es inmenso, pero puntualmente en países en vía de desarrollo, en mi caso como Colombia, tenemos muchísima información disponible, pero los datos no se están aprovechando. Es por eso que el tema de la interoperabilidad es fundamental abordarlo, y asimismo el tema de el almacenamiento de los datos, o sea, ¿dónde los vamos a almacenar? En el proyecto, y con esto termino, Ricardo, almacenamos datos por un año y el recurso que nos fue entregado, digamos, se llenó y no fue posible continuar almacenando. Entonces, obviamente todo esto cuesta, entonces hay que pensar en presupuestos para, digamos, disponer de buena tecnología para el almacenamiento de los datos. Interoperabilidad y pensar en almacenamiento de los datos con calidad y seguridad.
Perfect. So Javier, well taken. Several points here. What he was suggesting is the universe of data in healthcare. It's immense. However, data is currently disjointed, separated, disaggregated. So we definitely need to work towards interoperability standards so that this data can be shared across platforms and we can actually make the best out of this data universe. Of course, besides the interoperability, you also need to store the data. And data warehousing and data storage is not only complicated, it's expensive. So we also, as a community, need to work on ways that we can provide centralized data repositories that are interoperable and could be used then for research and for furthering the knowledge for clinical biomedical engineering. And of course, let's not forget that these repositories need to be kept safe, so the cybersecurity aspects are also paramount. Thank you.
And let me point out, devices like the Apple Watch now have the ability to do heart arrhythmia detection and pulse oximetry and other measurements, and they're wearable blood pressure monitors. And that returns to the challenge of provenance. How trustworthy is that data? Apple has indicated that their heart monitoring and arrhythmia system is FDA approved. However, they say it's not a medical device. It is a consumer device for the hobby of watching your heart, I suppose, and recommend that you see a physician if there's an issue. But I think it's a sign of the direction that we're headed in. And if you look at the home oximetry program that the UK created, it's called COVID at Home, and oximetry at home. This is a program that's been in existence for over a year that sends patients home with a pulse oximeter to manage their health and prevent unnecessary hospitalization or accelerate the return of the patient to the home for monitoring. So we're seeing some very remarkable changes happening in healthcare. And you'll be hearing about a presentation that our colleague Dan Clark will be talking about coming up about some of the work that has been done in that area. So the clinical engineering community has to really concern themselves with data quality. What does the data mean? What are the limitations of the data? And we have the further challenge of not overburdening the physicians and nurses. We are sort of buried in an avalanche of data, and we need tools. We need smart tools, sharp tools to help us improve healthcare. Shall we move on to the next question? We had a question that was posed to us all. It's not in the Q&A box, but about progress in interoperability of data. And there are massive programs underway around the globe largely stewarded by HL7 and IHE, integrating the healthcare enterprise. And the two together in collaboration with HIMSS have created a global consortium related to data interoperability. And this will lead to more and more convergence. That's the good news. The bad news is there's going to be more and more and more and more data at a very, very high rate. And that includes genomic data, which will be part of personalized medicine and medical care. So, stay tuned. This is happening in real time in our lives. Our clinical engineering community has a direct input into those interoperability activities. And if you're interested in becoming part of those, send me information, your contact, and I'll put you in touch with the IHE and FIRE, HL7 and IEEE programs working in that space. Another question that was asked is lessons learned from digital health startups supported by universities. And there are many, there have been spin-offs from universities, spin-offs from Google, from IBM. Ricardo, are there any that you would like to identify or point to?
Well, more than identify or point to, I would like to follow up on what you've been saying about development, integration, interoperability. Both you and I were at HIMSS last week, and I was happily surprised of a couple of things. So the interoperability showcase was much more truly interoperating than in year prior. The companies were presenting not just their collaboration inside the showcase, they were presenting their interoperability outside in the main conference room. So interoperability has become a banner for the healthcare space, whereas people a couple of years ago were a little hesitant because I want to protect my territory. Now everybody's using this as a banner. We need to share information and we need to comply with standards. And Elliot is the best person to connect you with all of these standard organizations, founding members of IHE. He is related with this interoperability space. So no one better than him to connect you with this community. So take advantage of that. And another thing that we saw at HIMSS were twofold. So there were some traditional IT companies that, yes, they have purchased some health informatics companies, but this year they were going as themselves. So they were there as Microsoft, as IBM, as Cisco, as Workforce, presenting how this IT is actually permeating every aspect of healthcare. So there has been spin-offs from healthcare, there's been spin-offs from IT, there's been spin-offs from universities, and again at HIMSS, there were a lot of new startup companies that came from all of these different experiences, and they were all talking the language of interoperability. So it's a very exciting time right now.
I'll also let's move on to that other question that was posed about spinoffs or expand on that. Universities are leading the way in many areas. For example, in artificial intelligence, looking at X-rays, Stanford University has released a public database of over 100,000 X-rays that are annotated by physicians, expert annotations to use for training sets for machine learning and AI. MIT and Mass General have been part of a similar collaboration with the American College of Radiology. I think they have 300,000 such samples. We've actually had cardiac arrhythmia databases now for 35 years. They're the standard of care available for all arrhythmia monitoring around the world. The Beth Israel Deaconess database and the MIT database. And so universities are really pushing the envelope on sharing information that is used in commercial products. There are many algorithms that are have been patented that are working their way through FDA and international approval. In terms of courseware, there are a variety of courses that are offered. Ricardo and I teach a digital health program at Villanova University that is focused on a number of these topics, and we've been doing that for much of this decade. There's a lot of material available actually within our own ICEH-TMC proceedings on these topics as well. And there are a number of textbooks that we can refer you to that have information. One aspect of this that is quite large is the whole data sciences side, all of the data analytics and data representation, and there are also textbooks in that space. I saw one question which was from a colleague who was asking about whether, let's see what that was, whether whether IT people can become trained in this area. And look, I've been saying for 15 to 20 years, as far as I'm concerned, IT people are actually clinical engineers. They just don't know it. 20 years ago, they were working on billing and administrative. Today, they're working on life-critical information systems, and they just don't fully understand the responsibilities that they have. And I think we should deputize them. I believe that this creation of a credentialing program would be a tremendous opportunity to bridge that area between those two disciplines. Now, we have colleagues who identify themselves as software engineers and software architects that have a reasonable portion of the story, but we can make it a lot clearer for them and make the roadmap a lot clearer. And honestly, most of us are not going to learn programming. Most of us are not going to learn database administration. Most of us are not going to become data scientists. We need to create collaborations and partnerships. Would anyone else, one of the other panelists, like to offer perspectives about this?
I think it would be good to hear from Fabiola and Nelson about their experience with the consortium, because they are working with industry, with academia, with government, and they are moving forward in helping improve healthcare in Colombia. So I think getting a little bit of their insight would be of importance.
You said Fabiola, you may meant Beatriz.
Nelson, Beatriz, sorry.
A nosotros pues nos parece importante tener en cuenta que desde la academia hay que formar a los profesionales y a los ingenieros para que empiecen planeando y que le den esa prioridad a la planeación sobre el trabajo que hay que hacer frente a la salud digital. No es empezar a hacer porque tenemos muchas ideas de cómo hacer y qué vamos a ejecutar. Es planear lo que vamos a hacer, tener claridad de los datos que vamos a obtener y tener claridad de los algoritmos que necesitamos para poder trabajar con ellos y ofrecer un servicio o mejorar un servicio de salud para la comunidad. Adicionalmente, porque hay un requerimiento alto de modificaciones en infraestructura y en gestión en infraestructura y en gestión para lograr que este tipo de desarrollos se puedan dar y esta tecnología pueda entrar a trabajar de la mano con el personal asistencial en salud.
Okay, déjame traducir. So this is very important what Beatriz is just mentioning. So she thinks that academia has a very specific function when educating engineers in the field of digital health. And it is on the order of prioritization and planning. Engineers need to learn how to plan for what's needed and how to prioritize those needs to provide the best solutions. Not only that, but innovation in all of its dimensions. And that's part of what they're organizing for the oncoming Clinical Engineering Congress in Colombia, that you can innovate not only in the hardware or the software, but you can innovate in how the infrastructure is organized and arranged, how is it managed, how is it serviced. So there are a lot of areas for innovation in the broader field of clinical engineering and information technology. I don't know, ¿quieres decir algo más, Nelson?
Adicionalmente, Ricardo, nosotros hemos visto que desde nuestros egresados se están abordando todas estas temáticas. Inclusive hemos tenido egresados catalogados dentro de las personas menores de 35 años con más perspectiva o con más influencia por MIT, que trabajan este tipo de temas, han generado empresas que muchas de ellas pues han logrado patentar dispositivos hechos por las universidades y que ellos han comercializado. Estas están generando todos estos datos que están siendo almacenados e inclusive nuestros egresados están también generando software y apps que permiten complementar, como decía Elio, toda esta información pues para Apple, para todas estas grandes empresas, pero buscando siempre que toda esta planificación que les enseñamos desde el pregrado se pueda implementar en el posgrado, dándole una fiabilidad a los datos que estamos obteniendo. Inclusive creo que Javier en su tesis pudo comprobar algo de esto por el trabajo que tuvo con sus egresados y con los que tenemos, pues afortunadamente somos pocos acá en Colombia. Y adicionalmente en la ciudad tenemos una iniciativa que es el clúster de salud Medellín Health City, en el cual muchas de estas empresas se unen para solucionar retos de ciudad o retos que las mismas empresas tienen con respecto al manejo de toda su información, sus datos, almacenamiento, transmisión, seguridad y todo este tipo de cosas. Entonces, creo prudente poner esta experiencia sobre la mesa para que todos la conozcan y pues mostremos que estamos trabajando en el tema. Muchas gracias.
Excelente. So this is super important what Nelson is saying, and it actually goes back to the prior question on innovation and spin-offs from university. So actually, again, Medellin is a great example of collaboration for universities, two public universities, two private universities, all working together to improve healthcare. There is an initiative at the city of Medellin that's called Medellin Health City, where they have a health cluster, and there are grand challenges that are proposed by the community of healthcare, where the students actually have the opportunity to abord these challenges and provide solutions. And to that point, several companies have actually come out of this cluster. Even one of them has been recognized by MIT as one of the under 35 years of age innovators with greater potentials in Latin America. So this is a great way to learn how to integrate academia into the improvement of healthcare. So again, I would like to invite you all to learn from this excellent cluster. And like they've always say, next year, the conference should be very interesting for all of us.
Right.
So another question that was posted is asking about challenges for leading a certification process, including engineers and perhaps even non-engineers who have many different specialties. Do you want to talk about those challenges, Ricardo? Because they are complex, and
I agree.
We have, for example, physicists who are responsible for radiology equipment. We have pathologists responsible for lab equipment. Many of them have developed very sophisticated digital skills, AI, ML, and other skills. Would we not want to include them and embrace them in some kind of certification and education program?
Good question. So the American College of Clinical Engineering, since its inception, actually opened the door for professionals that were not necessarily engineers, but were actually providing to the body of knowledge of clinical engineering through their experience. So the board of examiners can actually evaluate a professional regardless of their baseline skill and determine whether they would qualify to sit in for the clinical engineering exam. This CEIT would be a new proposal. And yes, we would need to have also some onboarding or minimal requirements for someone to become part of the accreditation process. But I definitely don't think that it should be locked only to a specific profile, because that is not what we're seeing in the field of CEIT. Like you mentioned, Elliot, pathologists, radiologists that are doing excellent things in the field. So we cannot discard managers. There's a lot of healthcare administrators that are actually innovating through the use of health IT and incorporation of relevant data for their decision support systems. So I don't think we should eliminate anyone from the potential pool of candidates.
So one other challenge is that we have to realize that there are other professional certifying bodies for pathologists, for medical physicists. So in a perfect world, we would do this in a joint way, in some way that would recognize credits, so that an individual who came to a course would also be able to apply those credits, or at least partial credits, in both directions. I guess another challenge that we have in this approach is that technically the certification process has to be separate from the education process. There has to be a complete arm's length separation. The people who are passing certification or examiners can't also be doing the teaching. That's a conflict of interest. Do you want to speak to that just for a moment?
Yes, sure. That is definitely a conflict of interest. And that is why precisely I was proposing that the content generators need to be separated from the evaluators. So the American College of Clinical Engineering created the Health Technology Certification Commission precisely to do that. So the Health Technology Certification Commission is an independent body where there is a board of examiners. This board of examiners are all certified clinical engineers that are not participating in any of the educational programs. So they are just there to validate the knowledge based on a body of knowledge that is also determined by another board within the American College of Clinical Engineering. So we have the body of knowledge defining what are the aspects that a clinical engineer should dominate. Then there's the board of examiners that is going to validate whether the candidate is actually fulfilling and meeting the minimum requirements from this body of knowledge. And a completely separated, arm lengths apart, you have academic institutions or you have independent consultants that are providing training for the clinical engineers in order to take the certification exam. But there's no relationship whatsoever between these entities. So again, here we have a content generation provider, could be an academic institution, could be HIMSS, could be like you said, American Society of Pathologists. They might have a formal course in lab information systems. And
Right.
maybe we could validate whether the credits of the lab information system, at least partially, could be transferred to this continual education process. So yes, again, like I said at the beginning, this is just a proposal. There's
Okay.
still a lot of things that we need to solve, but I think we're moving in the right direction.
Well, that's great. And I'll also comment that we have international liaison that has to be identified, because we have 10,000 certified clinical engineers in Japan. We have many tens of thousands of clinical engineers certified in China. And we would be wise if we had some kind of collaboration, maybe through the Global Clinical Engineering Alliance, to make everybody aware of each other's programs. We have a hand up from Fabiola, and so Fabiola, invite you to the discussion if you'd like to come on camera and open your mic.
Okay, thank you. My camera is not working well.
Okay.
So, and I will feel more confident if I speak in Spanish.
Perfecto.
Ok, bueno, primero felicitaciones a los ponentes. Creo que lo que nos han compartido nos va a ser de mucha importancia para los que estamos desarrollando este tema en nuestros lugares de trabajo. Yo quiero poner en la mesa el punto de los datos. La pregunta de la calidad de los datos me parece importante porque si bien los esfuerzos de universidades como Stanford y el MIT de compartir sus bases de datos para poder desarrollar métodos de aprendizaje maquinal, en el contexto de nuestra realidad funcionan solo para probar el algoritmo, más no para ver el impacto en el mundo real, en este caso en nuestro entorno. En este sentido, por lo pronto el gobierno de México ha hecho un importante esfuerzo por compartir la información que en el caso del Ministerio de Salud desarrollan a través de la transparencia de una cosa que se llama transparencia, ¿no? Yo he tenido la situación de consultar esos datos y corroborar que son, como bien decían, inconsistentes y con una cuestionable pues calidad, ¿no? Entonces, creo que uno de los puntos que se tienen que considerar es la manera de cómo poder interactuar con el que genera la información, ¿sí? En este caso, con quien los libera de manera oficial y poder ponernos de acuerdo en que esos son los datos reales y esos son los datos confiables, porque pues las investigaciones dependen mucho de ello. Muchas gracias.
Muchas gracias, Fabiola. Y sí, eso tiene que ver con lo mismo que había dicho Javier, pero déjame traducirlo, muy importante. So Fabiola wants to come back to the importance of data quality. Elliot mentioned all of the academic databases that have been created for that purpose and that how those are considered not only official, but the paramount reference against which you compare, for example, all of the arrhythmia algorithms that have been tested for 30 years against the MIT database. But Fabiola wants to come back to the quality of the data, not in the context of the university and research, but in the context of the real world experience. And that also has to do with what Javier was mentioning. How do you actually interact and train the content generator, the doctor, the nurse, to actually provide consistent information, consistent nomenclature, for example. What is the proper nomenclature to refer to a specific condition, illness, disease? World Health Organization has done a lot by defining multiple systems of classifications, like the International Codification of Diseases, ICD, currently version 11, but there's more. There's the International Classification of Health Interventions, ICHI, which is also very important. And then you have SNOMEDs and other nomenclatures that could definitely be used to strengthen the quality and the transparency of data. So another thing that Fabiola's mentioned is that Mexico has actually created an instance within the Institute of Health precisely to look for transparency in health information. But there's still a long way to go into making this in a standard fashion.
So
Elliot?
part of my life is spent in this informatics space, and my doctorate is from the information sciences side. This is an enormous juggernaut. You don't have to look any further than WHO and our colleagues working on a nomenclature for medical devices. We will not ourselves solve this. And we will not get agreement in India that Ayurvedic medicine or in China that traditional Chinese medicine needs to abide by our Western cataloging methodologies and languages. I think this is one of the big challenges that we have. It's an information sciences challenge. It's part of the human, the semantic interpretation of medical information. And different countries, different cultures place different emphasis on these areas. I put in the chat box a statement I'll verbalize. We can't let perfection be the enemy of good enough. This field is rapidly moving. We need to intercept it and become active, respected participants and leaders in this field. And we need to identify those leaders at WHO who are dealing with nomenclature. We have to talk with the folks at SNOMED who have a lot of licensing hurdles to access their coatings. There are so many opportunities and challenges, but again, those are all part of the digital health convergence and part of, I think, our obligation to teaching students and teaching researchers and teaching faculty is to make them understand, help them understand the diversity of these languages, and in some cases, the kind of frustrating perversity of some of these languages. And I'll also say that we're moving into the consumer area, and the consumer's ability to understand complex chemical, genomic, technical, and other terms is really limited. And so that is also an aspect that is not well defined and understood. And if we're going to expand our discipline to deal with home care, the geriatric aging population, people with multiple simultaneous morbidities and diseases and challenges, we are going to have to build a more facile, more flexible, a better educated workforce. We're winding down to the last minutes. So I'll ask each of our presenters if they could just offer, one thought for everybody to share. Javier, can we start with you? Do you have one thought to share?
Una idea, Javier.
Una idea, no. Trabajar definitivamente en equipo y de forma multidisciplinaria. Esto es no solo ingenieros, sino trabajar de forma multidisciplinaria.
Multidisciplinarity is his end thought. This is not a problem just for engineers. We need to work together.
I have said for 10 years that I am a Swiss Army knife.
Yeah.
With lots and lots and lots and lots and lots of different pieces.
Yes.
Beatriz, would you like to share a thought?
Yo creo que la unión hace la fuerza, entonces es importante que empecemos a buscar la oportunidad de interactuar y no solo entre los del mismo país o la misma región. Este tipo de grupos que nos permiten interactuar de forma, ver las diferentes visiones que hay en los diferentes lugares, nos va a permitir generar una tecnología que sea más abierta al mundo y que pueda ser más inclusivo. Entonces ahí sería el punto de partida y creo que la visión es desde la educación, ¿cierto? Desde la formación de los ingenieros.
Me gusta. So what Beatriz is saying is that not only it's about multidisciplinarity, it's about working in the global spectrum, in the global consortium, learning from the different cultures so that we can build solutions that are more inclusive and more pertinent.
Excellent. Fabiola, would you like to offer some thoughts? I'll ask one comment and then we'll go to Tom.
Oh, thank you for the opportunity. Well, I have a call from my colleagues on the importance of working together and getting a better assistance for data information and data sharing. Thank you.
Tom, would you like to share some thoughts? A final thought?
Just that clinical engineers undervalue themselves. We, as Ricardo was sharing earlier, there's in Kaiser Permanente, large health system in the US, we partnered very well with IT, we clinical engineers, and there was 10 different ways, besides just integrating medical devices into electronic health records, but 9 other ways that were very significant in the way, the future of healthcare is going. Clinical engineers can really make a difference. Over.
Excellent. Ricardo, do you have one thought to offer?
2 things. Ethics. How do we build ethics into all of these IT solutions And second, and that's related to what Fabiola and you were saying, how would we integrate traditional, complementary, and alternative medicine into the continuum of care?
Great. Thank you. And I'll close with this thought. That's what I think all of us are. I think that's what all of us need to be. I think in many ways, that's what all of us have been in our careers. We are multidisciplinary, cross-disciplinary, and we wake up every day caring about patients, caring about physicians and nurses, caring about really the planet and wellness and equity. And so this is a everyone play exercise. We encourage everybody to please participate, offer your thoughts, energy, time, insight, brilliance. And thank you to everybody for all the hard work that the last couple of years of the pandemic has required from everybody. And be safe and be well. And thanks for joining us today.
Thanks, faculty. Bye.
Thank you, faculty.
Bye-bye.
Thank you.
Thank you.
Bye-bye.
Thank you. Bye-bye.